Now I will tell you similar problem of IMO is what. Now let's start angle bisectors. For angle bisectors, again the property. The main property is that when we have an angle, a point is on angle bisector if and only if the distance from these two sides are equal, right? Okay, we call this one x, this one y. A1 is equal to A2 if and only if Px is equal to Py, right? It is the definition, and we can prove it by congruent triangles easily, right? Okay, proof, you can do it as homework. It's so much easy. Homework. Now, do you know angle bisector theorem?
Yeah.
Angle bisector theorem is what?
Where E is equal to AC over CD.
Exactly. By angle bisector theorem, we can say BD over DC is C over B, right?
Yeah.
Now, the proof is what? It has many proofs, okay? Yes, it's a lot of ways you can prove this. So, try to prove at least with one way. You said what? Exactly. So, one solution. And let me tell you general form. General form, this one can be useful. This one is for any triangle and any arbitrary line through A. Suppose it is P. A1, A2. Now, have you heard ratio lemma?
No.
So much useful. In problems of AIME, use some also useful. It is general form of angle bisector theorem. It is what? Let's use, as you said, sine law in triangle ABP. Okay? So it will be sine A1 over what?
BP.
Yes. Equals. Let's write P1, P2. Sine P1 over what?
AB.
Yes, AB or C is equal to sine B over what?
B over AP.
Exactly. Now if we use sine law in triangle APC, sine A2 over what
PC.
is equal to sine P2 over what?
Oh,
Yes, AC over B. Or B sine C over what? Yes. Now if we divide, we can say sine A1 over sine A2. If we consider first two fractions, it will be BP over PC times B over C, right? Agreed. Also, you can write times sine B over sine C, okay? Memorize this, and we call it ratio limit. Now, do you agree this one BD over DC? Why angle bisector theorem is a special case of ratio lemma?
because B1 is equal.
Exactly. And BD over DC times B over C is 1, so it will be C over B, right? Okay. Now, so this one, I know this, memorize. Now calculate BD in terms of ABC. Okay?
Let the sine lengths would be
BD, this one, in terms of ABC side lengths. Okay?
C over B plus C times A?
Yes. Why?
Sorry.
Yes, we can also say, we can say BD plus DC. BD over BD because of the first fraction. Can you tell me BD over BD plus DC is what over what?
Uh,
No. C over B plus C.
no.
Right? You should do same thing here. BD plus DC is what?
BD plus DC is A.
Yeah, so BD is AC over B plus C, right? Similarly, you can say CD is AB over B plus C, okay? Memorize also these two things, okay? Now, let's work on rest of the ideas in angle bisectors. Now we want to find the length of like median. We want to find length of internal angle bisector. So up to this part, it is AC over B plus C. This one is AB over B plus C DC. Let's call this one ADDA. I want to find two formulas for DA. Do you know any formula for DA? And if you use the Stuart's theorem, you will reach BC minus BD times DC. Okay, or we can say BC minus A squared BC over B plus C squared, right? Proof, you can prove it by Stuart's theorem, homework 2, okay? And dA is squared. Memorize this. Have you seen this before? BC minus BD times DC?
No.
Okay, now we want to work here. It is dA squared. Now we want to find a formula for dA. dA is 2BC over B plus C cos A over 2, okay? Try to prove this formula now.
Okay. Yeah. So I did sine area for
Okay.
CD times sine 2 plus 1 half BD times sine 2 equal to 1 half BC times sine.
Okay, let's write 1/2 CDA this area. Sine A over 2 plus 1/2 BDA. Sine A over 2 is what?
Is 1 half BC times sine A.
Yes, then what?
I get D equals BC over C times sine A over sine.
Yes, you can say DAB plus C. We can factor from sine A over 2 and dA. So because sine A is 2 cos A over 2, 2BC cos A over 2, right?
Yeah.
So dA is 2BC. Good job. 2BC over B plus C cos A over 2. Good job. And let me draw a rectangle around this to memorize. Next one on. Prove it is proof 1. We could also prove it by applying sine law in one triangle. Let's apply sine law in triangle ABD. If we apply sine law in triangle ABD, we can say sine A over 2 over what?
Over BD.
BD, or we can say AC over B plus C, right?
Yeah.
Is equal to sine B over what?
DA.
Exactly, BA. Now, let me maximize. Okay. So we can say what? We can say dA is AC sine B over B plus C over B plus C times sine A over 2, right?
Okay.
Do you agree A sine B is B sine A by sine law in triangle ABC?
Yeah.
Okay, so, and we know sine A is 2 sine A over 2 cosine A over 2, 2BC over B plus C cos A over 2, right? Okay, so we've considered, let's review what angle bisector theorem, BD, DC, DA we found. Now, we want to prove why angle bisectors, we proved why medians are concurrent, right?
Yeah.
Now for each line, we want to prove this. Internal angle bisectors, internal angle bisectors are concurrent. Try to prove this one.
Okay, wait, I don't know if this is a valid proof, but
So look, in circle of ABC, we can prove that it exists if we prove that they are concurrent. Okay?
Can see the circle exists. Just go to the insert.
Yes, you can. If you prove there exists a circle that is tangent to all sides, yes. You can say, okay, they are concurrent. What we want to prove it is concurrent, then prove that there exists in circle, okay? Okay, try.
I don't know. Prove.
What was the approach for proving that 3 millions are concurrent?
I don't remember.
Okay, when we proved that, I told you that we use this approach for other lines. I told you we drew 2 of them, right?
Yeah, I drew 2 of them. I tried to prove it.
Yes, and proved the intersection. The intersection lies on third one, right?
Yeah.
Now here you should do same thing. One more hint or that's enough?
I'm trying to do.
So let's draw 2 angle bisectors, for example, B and C. Okay?
Yeah.
And then we can say what? Let's draw this. Suppose it is, for example, BD, CE. Suppose this one is I. Now, if we draw 3 perpendiculars, this one, for example, this one, let's consider this one is IX, this one Y, this one Z. Okay? Let me erase. Now we know I lies on what? I lies on 2 of angle bisector of B, right?
Yeah.
I lies on angle bisector of B. So what can we conclude?
I see 2I.
Exactly. Also, we can say I lies on angle bisector of C. So what can we conclude?
I'm going to go bisector of C. So I'm one.
So from these 2 things, we can conclude what?
IX equals IY is IC.
Yes. IX, or we can say IZ is equal to IY, right?
Yeah.
IZ equals IY means I lies on what?
Uh,
Angle bisector of what?
less.
Yes. So we proved, right? So internal angle bisectors are concurrent at I. We call I what?
In center.
Exactly. I in center. And if we consider Ix equals Iy equals Iz is R, we call it what?
In radius.
Yes, in radius. If we draw a circle with center I and radius R, then it is what?
Tangent to the lines.
Exactly. It is tangent to AB, AC, BC, right? We call this circle what?
The end circle.
Exactly. Okay. Now let's work from here on properties of this circle. But before that, so Control C. Well, let's draw a triangle. This one, this one. Let's consider this. Okay. It is A, it is B, it is C. It is our circle. Now I. Okay. So the next theorem is what? Do you know the formula of in radius is what?
In radius times the perimeter is equal to area.
Exactly. Why do you know the proof?
Yeah, it's just like AB times 2 plus
Yes,
C.
exactly. Area of ABC, you can write area of AIB plus area of AIC plus area of BIC, right?
Yeah.
So you say, okay, area of ABC, AIB is R times C over 2, AIC R times B over 2, next one plus R times A over 2. So it will be equal to R times C over 2 plus B over 2 plus A over 2. So it is RS. So we can conclude R is equal to area of ABC over semi-perimeter. Now, next one. Suppose, again, we have this in-circle, and suppose, for example, we consider this one D, this one E, this one F. AE is what in terms of ABC? Okay? Calculate this.
I don't know.
Okay, so, and can you tell me equal lengths are what in this figure? Yes, what else?
C plus DC.
Yes. So do you agree we can call it X, X, Y, Y, and Z, Z?
Yeah.
Okay. 2x plus 2y plus 2z is what?
Um,
Yes, or 2 times semi-permanent, right? X plus Y plus Z then is equal to what? Exactly. So AE is what? Yes, it's X, which is S minus Y bracket Y plus. Y plus Z is what? So it is S minus A or B plus C minus A over 2, right? So X is S minus A. Similarly, Y is what?
Y is minus B.
Yes, and Z is what?
This one C.
Okay, memorize these three formulas, okay? Okay, now let's see. Now when you see a problem about angle bisectors, maybe you have this in circle. Now you know all these lengths in terms of ABC, right? And we know length of internal angle bisector is what? We found two formulas for that. We found in radius is what? Now let's work on other properties of angle bisectors. Suppose we want to find ratio, or let me tell you, AI. We want to find length of AI. But before that, we should find an important ratio. AG over GM was what?
What's G?
G was centroid.
Centroid 2 to 1.
Exactly. Now we want to find ratio of AI over ID. And we have an important formula. It is B plus C over A. Okay? Try to prove this one. So AG over GM is 2 over 1. But for I, it is B over C over B plus C over A. Try to prove this one first on your own. Okay?
Okay, so if you just connect BI, if you just connect B to I, then you get another.
Good job. Completely correct. If we connect this, then we can say AI over ID is what over what?
AB over BC.
Yes, ABC over BD. The formula of BD was what?
BC over B plus C.
Exactly, AC over B plus C. We can cancel. And it is B plus C over A, right? Okay, good job. And we know B plus C over A is greater than what? 1, right? Why is greater than 1?
Triangle or
Exactly, good job. Now, next theorem. We want to find length of AI. Try to prove AI is BC over S cosine A over 2. Okay? Try this part.
Okay, so I did it like this. Kind of weird. So I said, so I have AI is equal to BC.
The first multiple those.
Let me write again. You first did what? So it will be RBC cosine A over 2, right?
Multiplied
Sine A over 2 RBC. It will be then sine A. Here sine A over 2. Here this one, right? Then what?
So to BC times
Uh-huh.
sine A over 2. I guess sine A over 2 times
Which is correct, right? Because this one. R is AI sine A over 2. Yes, completely correct. Let me tell you another approach, proof 1, proof 2. We proved that AI over ID is what?
B plus C over A.
Exactly. But do you agree we know AD is what, right?
Yeah.
So we can write AI over AI plus ID, right? Is equal to what?
Equal to B plus C over A plus B plus C.
Do you agree it will be B plus C over 2S?
Yeah.
AI plus ID is AD, right?
Yeah.
So this one is AD. AD, the formula of AD was what?
2BC over B plus C times cosine A over 2.
Exactly, times cosine A over 2 times B plus C over 2S, right? B plus C cancel, 2 cancel. So we can say AI is BC over S cos A over 2, right? Okay, so we prove this. Memorize also this one. So I told you length of AI. I told you this one. Now, next step. We draw this one and let's consider circumcircle and we will consider important properties of circumcircle when we are working on angle perpendicular bisectors. But here, let's consider one property. Suppose it is T and it is I. Do you know in this figure what lengths are equal?
Uh,
TB, TC, TI are equal, right? Why? Have you seen this before? Okay, so try to prove this. I is in center, not in center. Try to prove this.
I don't know.
Okay. For this one, you should only use angle chasing. Okay, to prove this. Want me to tell you or want to prove it on your own?
I'm not sure, so I guess.
Okay, so let's draw. At first, TB is equal to TC. Can you tell me arc BT is what? No, exactly. Because of inscribed angle, when it is A over 2, it is twice that. It is A. Arc TC is what?
TC is
So from here, we can conclude what?
TB. TC.
Exactly. So because arc BT equals arc TC, we can conclude what?
Or you can conclude on this. See?
Yes, chord BT is equal to chord CT. So we proved this one, right? Now we should prove TI is equal to one of them, right? Want me to tell you why TI is equal to one of them or want to prove it on your own? Let me connect. Can you tell me this angle is what?
C over 2.
Exactly. This angle is what?
Um, it's also C over 2.
This angle is what?
Change one that tone.
This. Exactly. Good job. This angle is what? No. It's not center of this circle. It is in center. Center of this.
It's A over 2 plus
C over 2.
Exactly. Exterior angle. Sum of two non-adjacent angles. So we can say it is equal to A over 2 plus C over 2, right? So this angle is equal to this angle, right? So isosceles triangle TC is TI, right? Angle CIT is equal to angle ICT, so we can conclude they are equal to TI, right? Okay,
It's,
understood?
yeah.
Okay, now we want to say something. TB is equal to TC is equal to TI is equal to A over 2 cos A over 2. Try to prove this.
TB equals TC. I don't know. Not sure.
One hint?
Yeah.
Okay, so let's see. Let's try different ways to prove this. TI, So for TC, we can say, for example, TC over what is equal, if you use sine law in triangle ATC, it will be what?
Zeros.
It's equal to what?
Zeros.
Yes, or next one is what over what?
AC over
B over sine B, right? B over sine B is, do you agree, A over sine A? And A over sine A, do you agree, is equal, it is in triangle ABC. A over sine A, do you agree, is equal to A over 2 sine A over 2 cos A over 2?
Yeah.
So do you agree we can cancel this and this?
Yeah.
And do you agree it's A over 2 cos A over 2?
Yeah.
What was the reason you couldn't prove this? You wanted to prove TI or TC?
Could be 13.
TC is easier. Okay. So we said this, when I tell you external angle bisector, we will prove also it is equal to TIA. Do you know IA is what? Have you heard excenter?
Yeah.
Okay, IA is excenter of A. Okay? Okay, but I should tell you something about external angle bisector. Then I will tell you in, for example, USAMO 2023, this was useful. Something similar to that. So let's work on excenter. In next part,